Hi guys, welcome to the intro of completing the square, so AA1-9. We're going to start with finding the vertex, given a couple of different forms of quadratic equations, and then do completing the square to find it with the final way. So starting with the warm-up, when we're looking at factored form, meaning we have one factor, 2x plus 6, times another factor, x minus 4, and we use the zero product property, and the zero product property tells us that if we have two or more things multiplied together to get 0, then at least one of them has to be 0. So what we do to solve this is to set each part equal to 0. So, 2x plus 6 equals 0. So subtract 6 from both sides. So 2x equals negative 6. Divide by 2. I've got x equals negative 3. That's one of our x-intercepts, and I'll explain that part in just a minute, which I kind of glossed over. X minus 4 equals 0. Add 4 to both sides. So x equals 4. So my two x-intercepts are negative 3 and positive 4. Now, if I look at this graph, a quadratic forms a parabola, which we've obviously talked about before. This is my x-axis, and all along the x-axis, the y value is always 0. So this point is 0, 0. If I move over, I've got 1, 0, 2, 0, 3, 0, 4, 0, blah, 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 blah. Obviously, I don't have a grid there, but so the reason that the zero product property works is that I'm essentially taking 0 and plugging it in for y. So I'm making that 0. So when I use the zero product property to solve, it gives me my two x-intercepts. That's going to be important shortly. And then writing the equation in standard form. We did some work with this last class. We're just multiplying it out. Whoops, wrong color. So 2x plus 6 times x minus 4. 2x times x gives me 2x squared. 2x times negative 4 gives me negative 8x. 6 times x gives me a positive 6x. And 6 times negative 4 gives me negative 24. I'm going to combine my like terms, so I've got 2x squared minus 2x minus 24. So that is my standard form. Whoops. All right, so when we are finding the vertex, there are different ways that it is easier than others. If we start in graphing form, also known as vertex form or general form, the vertex is just the h and k. So there's no math for us to do. It's just a matter of making sure that we pay attention to the fact that the h is usually the opposite of what we think. If it's minus, the h is positive. So if I have y equals 2 times x minus 3 squared plus 5, then we have a vertex of 3, 5. In factored form, so when we have whatever our a values, this is also called intercept form. When we have that a factored out there. We have our root 1, which is the x-intercept, and our root 2. So x minus the root times x minus the root. So what we do in that case is to average the x-intercept, and we'll talk about that a bit more in a moment. And then our last option is in standard form, the ax squared plus bx plus c, we have two ways of doing that. One is to get x with a formula of negative b over 2a, and the other is by getting it in vertex form by completing the square. So that is the newer skill that we're going to be learning today, at least for some. For others, not so much. So that is our, those are our objectives today, and we're going to go through. So in vertex, finding the vertex from factored form. When we're in factored form, we get our x-intercepts like we talked about in the warm-up. And assuming, like right here, we have the picture of the graph, but let's assume that we don't have that. So we're going to put 0 in for y. So 0 equals x plus 2 times x minus 3. We set both parts equal to 0 using the zero product property to guide us there. So x plus 2 equals 0, x minus 3 equals 0. Solve both. So we have x-intercepts of negative 2 and positive 3. Now, because parabolas are symmetric, meaning they're exactly the same on both sides, the vertex is going to be exactly the middle of our two x-intercepts, so somewhere around there. So what we want to do is average the x-intercepts. So when we average numbers, we add them all up and we divide them by how many numbers there are. In this case, there's just the 2. So we've got x for our vertex is the average of the two x-intercepts. So negative 2 plus 3 divided by 2 because we have two numbers that we're averaging. So that gives us 1 over 2. Normally I would keep this in fractions, but for the sake of simplicity, I'm going to go ahead and put that as 0.5. This is true with several ways. Once I am in my, once I have my x value, then I'm going to get my y value. So I'm going to sub that in to the original equation to get y. So y equals, so I'm going back up here to that equation. So y equals 0.5 plus 2 times 0.5 minus 3. So y equals 2.5 times negative 2.5. So if I do that math, negative 6.25. So my vertex is the point, 0.5, and negative 6.25. And if I look at my graph, right there, we're going 0.5 and then down 6.25. So that makes sense. So that's how you find the x-intercepts find the x-intercepts, average them to get your vertex. So we have a couple practice problems. If I were you, I would pause the video and attempt those practice problems on your own. Watching on the second one that 3 that we have there does not come into play until you're getting y. So whether you pause the video or not, we'll go ahead and solve those. So first off, finding our x-intercepts, x plus 5 equals 0, x minus 7 equals 0, subtract 5, add 7, so y equals negative 5, and not y, sorry. X equals negative 5, and x equals positive 7. So next up, we're going to average them. Excuse me. So to get the vertex, x for our vertex equals negative 5 plus 7, all divided by 2. Negative 5 plus 7 is positive 2. Divided by 2 gives us a positive 1. All right, so then we find y. Going back to our original equation, so 1 plus 5 instead of x plus 5, and 1 minus 7 instead of x minus 7. And then we just evaluate the math. So 1 plus 5 is 6. 1 minus 7 is negative 6. Remember, we're multiplying those two because they are factors, so multiply factors to get negative 36. So the vertex on this one is the point 1, negative 36. On the second one, I'm going to start the same way. I'm still using the zero product property because I am multiplying 3 times x minus 4 times x plus 6. So I have 3 factors here, but I can't set 3 equal to 0, so I'm going to toss that one out because once this is 0, the whole thing is 0 anyway. So 3 times 0 times 20 would still give me 0, for example, just throwing that out. So I'm going to set my factors equal to 0, x minus 4 equals 0, x plus 6 equals 0. So add 4 minus 6. So x equals 4, and x equals negative 6. Once again, I'm going to average x-intercepts to get the vertex, and I just keep writing vertex here so you don't get confused by all the x equals. So 4 plus negative 6 divided by 2. 4 plus negative 6 is negative 2 divided by 2. By the way, if you put this into the calculator in one shot and you do 4 minus 6 divided by 2, you need to make sure to put parentheses around the 4 plus negative 6 or 4 minus 6. If you don't, it will divide 6 by 2 first and then add the 4, which is not what you want. You want it to be the top divided by the bottom. Okay, so so that all equals negative 1. And then I find y. And this is where that 3 comes into play. So original equation is 3 times x minus 4, so negative 1 minus 4, times x plus 6, so negative 1 plus 6. And then I evaluate. So 3 times negative 5 times positive 5. 3 times negative 5 is negative 15. I'm going to drop down the times 5. And y equals negative 75. So my vertex there, negative 1, negative 75. So something that's important, one of the mistakes people tend to make when we do have a number out here is they want to multiply 3 by negative 5 and 3 by 5. And that is multiplying by 3 one too many times. So when you multiply, you're just straight across. 3 times negative 5 times 5. So if you just pop that in your calculator, that works as well. Some people choose to distribute at the beginning of this problem. If you do that, 3 times x, 3 times negative 4, you are not going to distribute it to this second part for the same reasons that I just talked about. You don't want to multiply by 3 twice because that would be like 3 squared instead of just 3. All right, so that is finding the vertex from factored form. From standard form, we have a formula, and I don't really like how this is typed out here, but I couldn't put it any other way. So negative b divided by 2a, and that's based off of our standard form of a times x squared. So a is the one that's always with x squared, plus b times x. b is the one that's always with x, and then c is the one that's always by itself. So we're not using c in this particular case, but on this first problem, the a value is 2, the b value is 12, and the c value is 13. So when I plug this into the equation or the formula, the negative from the formula is the place where people most often make mistakes. So I write this out every time without negative simplified to start. So negative and then b equals 12 divided by 2 from the formula times a, and a is 2. So I've got negative 12 divided by 4, which is negative 3. So that is the x value for my vertex. To find y, take my original equation, plug in -3 for all my x's. And then I evaluate. Now the biggest thing here is that you're using the order of operations, which is parentheses. There's nothing to do inside the parentheses on this particular problem. Next step is exponents. So that means that you are going to do -3 squared before you do the multiplication of multiplying by 2. So -3 squared is a +9. I'm going to drop everything else down. Next step is multiplication and division from left to right. So 2 times 9 is 18. 12 times -3 is -36, and then plus 13. And then it's addition and subtraction from left to right as well. These, by the way, are all y equals. 18 plus -36 is -18, plus 13, so y equals -5. So I've got the point -3, -5 for my vertex. On my next one, again, I would pause this and try this problem on your own if I were you. So either way, a equals -3, b equals -24, and c equals 8. This is where you have to be particularly careful with the negatives. So I start with my x using the formula -b. So if I have a negative from the formula, and then a -b, -24, divided by 2a, a is -3, so 2 times -3. Double -24 is a +24. 2 times -3 is -6, so I end up with -4. Most common error with this stuff has to do with negatives. That's why I recommend this first step, all the negatives still there, and then you simplify from there. So y equals -3 times -4 squared minus 24 times -4 plus 8. -4 squared is 16. I'm going to drop everything else down. -3 times 16 is -48. 24 times -4 is a +96. Drop down the plus 8. These are all, once again, y equals -48 plus 96 is a +48. Drop down the plus 8. So y equals 56. It's got the point -4, 56. All right, our final method we have is completing the square. And that has to do, what that stems from is a perfect square trinomial. So if you guys recall, we did this last class, x minus 5 squared. One thing you need to remember that this is not x squared minus 25. You don't get to distribute that. So this, whenever we square something, that is x minus 5 times x minus 5. I'm going to go ahead and erase that other part so it doesn't get confused. And then we have to distribute. So x squared minus 5x minus 5x plus 25. So x squared minus 10x plus 25. So this is what's called a perfect square trinomial, because it's the square of a binomial. And there's some relationships that are important. So we'll talk about that in the next screen. So, again, I would pause, do this yourself. Obviously, that's your call. On this one, I got x plus 8 times x plus 8. So that is x squared plus 8x plus 8x plus 64. So x squared plus 16x plus 64. Now, if you look at, we'll look at the other one too. X squared minus 4x minus 4x plus 16. So x squared minus 8x plus 16. So if we look at the relationship between the perfect square trinomial and the original, so we got x plus 8 squared for our original, x minus 4 squared for our original, there's different ways of looking at this. Half of 16 gives us that number 8. 8 squared gives us that 64. Alternatively, the square root of 64 gives us that 8, and 8 times 2 gives us that middle number. Same thing over here. Half of negative 8 gives us negative 4. Negative 4 squared gives us a positive 16. Square root of 16 gives us 4. 4 times 2 gives us 8. These two signs, middle signs there, always have to match. So our C value always going to be positive for a perfect square trinomial. And this relationship gets slightly complicated when we don't have an A value of 1. So it's really the 2 multiplied together times 2 gives us the center term. But what we'll talk about there is we're less dealing with completing the square when we have an A value that's not 1, except for the highly proficient. All right, so moving on. So based on that perfect square trinomial situation, we want to find the missing parts there. So again, I would try this on your own, see if you can do it paused, and then go over it. So the way I like to do this is to figure out what the parentheses squared would be first. So half of 8, so I've got x and half of 8 is 4, so plus 4, and then 4 squared gives me 16. Half of negative 10 gives me negative 5, so this would be x minus 5 squared, and then negative 5 squared would give me 25. Same thing here, square root of 64 is 8, so I know this is going to be x plus 8 squared, and then 8 times 2 is 16, so 16x. Now, this could technically be x minus 8 squared if that right there was a negative. So I'm going to put the plus or minus sign there, but those have to match. So same thing here, x plus or minus 9 squared to get that plus or minus 18x in the middle. Now, this relationship is important for what we're going to do next. Considering the equation x squared plus 10x minus 5, that is not a perfect square trinomial. If we wanted it to be a perfect square trinomial, so we'd have y equals x squared plus 10x minus 5. What we would want that third term to be is based on our b value. So we'd want this to be x plus 5 squared, which means we'd want that to be 25. So in order to make that 25, we have to add 30. And if we add 30 to one side, we have to add 30 to the other side as well. So what I'm going to do is add a page here. So I'll do this here. So y equals x squared plus 10x minus 5. So we want this term right here to be 25. So in order to do that, we need to add 30 to both sides. In order to do it legally, that's why we have to do it that way. We have to keep it balanced. So we've got 30 plus y equals x squared plus 10x plus 25. Now, x squared plus 10x plus 25, I'm going to drop down the 30 plus y, can be rewritten as that square of a binomial, so x plus 5 squared. Now, we have 30 plus y over on the left side, and whenever we write our equations, we want them to just be y, so we're going to subtract 30. So now I have y equals x plus 5 squared minus 30. Now, the reason that this is helpful is we're now in vertex form, A, H, K. So now all we have to do to find the vertex is do negative 5, negative 30. And that's it. So that is completing the square. There's a couple of practice problems. One is particularly challenging. I am going to go over that one in the video. So I didn't do it in class, but I'm going to move this up a little bit, that over. So first thing I need to figure out, for me anyway, is what my factored form would be. So I take half of that negative 12, so I get x minus 6 squared, which means I need this third term to be negative 6 squared, which would be 36. So in order to do that, I'm going to add 16 to both sides. So I've got y plus 16, because I already added it on this side to get that 36, and now I have it in the factored form. And then to get rid of it, subtract 16. So I've got y equals x minus 6 squared minus 16. And my vertex is 6, negative 16. So if you get comfortable with completing the square, finding the vertex in that method, for some problems can be a lot easier, but for other problems, like the challenge problem, it can be a little bit more difficult. So on the challenge problem, all of my perfect square trinomials I've been dealing with so far have had just x squared instead of having a different a value. So what I'm going to do is divide out that a value first. So on one side I have y divided by 2. And on the other side I've got x squared plus 5x minus 6. This is also more complicated because my middle term, 5x, is not an even number. So when I divide it by 2, I get a decimal. So in my factored form, this would have to be 2.5 squared, which means I want my third term to be 2.5 squared. And I'm getting my calculator up to make sure I'm giving you the right number. It's 2.5 squared. So I need that third term to be 6.25, positive 6.25. So if I need this whole thing to be positive 6.25, I have to add 12.25. And I can get that by doing 6.25 minus a negative 6. So that means I also have to add a 12.25 over here. So now everything on this side represents that perfect square trinomial of x plus 2.5 squared. So then what I want to do, that equals, whoops, not the right thing there. That equals 12.25 plus y over 2. So I need to subtract the 12.25. So I've got y divided by 2 gives me x plus 2.5 squared minus 12.25. Now I have to get rid of that divided by 2. So that means I'm going to multiply everything by 2. And that includes everything. So, Over here, I've got y equals. Over here, I've got 2 times x plus 2.5 squared. And then 2 times negative 12.25 is going to give me negative 24.5. And that is completing the square. So I have the vertex of negative 2.5, negative 24.5. That's the challenge problem. Completing the square when a does not equal 1 is going to be what's necessary for highly proficient on completing the square. So just be aware of that. All right, so that's it. For completing the square, we're going to do some more work on this when we get to the next section. It's going to have to do with circles as opposed to parabolas. So that's it.